Hello guys, welcome back to Maison African Motives, still on A-level mathematics on differentiation. We are going to focus in this platform on our algebraic expressions, but this time focusing on the type of ax plus b to the exponent of n, and more simply, let's just refer to this as f of x to the exponent of n. So I'm going to explain how we are supposed to have these derivatives in our simplest form. So take note, we had our basic introduction that we had. So in this case, we are simply moving on from that introduction. So let's say we are given y, which is equal to ax plus b, that is raised to a certain exponent, which can be a positive exponent, negative exponent, a fractional exponent. We can find this derivative of y with respect to x by performing a derivative with respect to the power, this power in this case, which is going to be n into ax plus b to the exponent of n minus 1. That's the derivative with respect to the power. And the derivative with respect to the algebraic expression, which is the one that we have in this case. And take note, we talked about this. If y is equal to ax plus b like this, the derivative of ax gives us a, the derivative of b, that's a 0. So that means our dy dx is going to give us a. So that is the one that you are going to apply in this case. So it's times a. So this a is from the derivative of this function that you have here. So now if we are to use it this way, it's going to confuse us because we can be given this is a x squared plus 3x, where we do not have a x plus b. So this part is going to give us a problem if it is like that. So let's take this it this way. If we are simply given the derivative of a function, we are simply saying if y is equal to a function of x, we are given a function that is f of x to the exponent of n. It simply means the derivative of dy with respect to x is going to give us the derivative of the power with respect to the power, which is n. So that's n. F of x is going to remain as it is, but to the exponent of n minus 1. Whatever that you're going to have, you find or you multiply to the derivative of the function that you're given, which is f prime x, or if this is y, whatever that you're given, dy dx or f prime x. So that is the simplest way that we can have this, which can be understandable because this can be a quadratic, not a linear like this, which means this formula is going to give us a limit. So this one does not limit us because any function can be differentiated as long it is raised to a certain exponent. Okay, so what are we simply having? We are simply applying what we refer to as the PA strategy, whereby that's PA strategy, whereby P is representing the power. So we are simply having the derivative, that is to differentiate the derivative with respect to the power. So that is the P. We are going to have the derivative with respect to the power, then the A representing the algebraic expression. So we're going to have the derivative with respect to the algebraic expression. So that's algebraic expression that we are given in this case. So the product now is the one that you are going to apply on your final answer. We are going to multiply the two, the derivative of this times the derivative of this. So that's how we can simply find the derivative of any function that is raised to a certain exponent. It can be also for trig exponents. I mean, whatever trig that is raised to a certain exponent. We shall talk about that one later on after I introduce the derivative of trig functions. I think that can actually help us a lot. All right, so let's get into questions, guys, and see how they can ask these typical questions. Let's say we are given a question in this case to find the derivative with respect to x. All right, so let's just take one question. Let's say y is equal to 3x plus 2 to the exponent of 8, and we are asked to find the derivative of y with respect to x, that is dy dx. All right, so we said we are going to have the derivative with respect to the power that is ignoring everything, okay? So we are taking this as our f of x, so that is going to be any f of x to the exponent of any minus 1. That is, we are going to subtract 1. We drop the exponent, we subtract 1. So this is going to be 8 into 3x plus 2 as it is. Then we subtract 1 on the exponent. So it's 8 minus 1, which is 7. So this is the derivative that we are having from the power. That is the derivative with respect to the power. Then we move on to the derivative to the algebraic or the trigonometric part. That's the one that you're going to have inside the bracket. So we are going to multiply to the derivative of 3x plus 2. So the derivative of 3x, that is 3. The derivative of 2, which is a 0. So we're going to have 3. Remember, I talked about this. I introduced this in the previous class where we say the derivative of y, which is equal to ax. If we are to differentiate this, we obtain a, and we have a given y, which is equal to a constant. The derivative of y with respect to x, that's a 0. So that is a 3, and this one is a 0. So you can multiply. 3 is outside of the bracket, 8 is outside of the bracket, so you can combine these terms together. So 8 times 3, that is 24 into 3x plus 2 to the exponent of 7. So that is what you're going to have on your final answer. So the derivative, take note, the derivative where we are given a certain bracket to a power, a certain power, we find the derivative of the power, we multiply to the derivative of what is inside the bracket, which is our algebraic expression. So this is what we are simply having in this case. The derivative of what is inside this is our f of it. So it's f prime x, or we can take it from the previous one that we started with. Okay, so let's have another question. The second one, let's say we are given in this case y, which is equivalent to x to the exponent of 3. So that's x to the exponent of 3 plus 2, everything to the exponent of 7. And we are asked to determine dy dx. So the derivative of y with respect to x, this is our f of x. So we are going to have, this is same as that presentation that we are given, f of x, everything to the exponent of n. So we are going to have this as to the exponent of n. This is what we had before. So this is your f of x. So from the formula or from the derivative of this, we said we are going to find the derivative with respect to the power, which is n into f of x to the exponent of n minus 1 times the first derivative of the function that you're given. So in this case, this is our f of x. Right, so you're going to find this derivative later on, but now let's focus with the power, which is 7. So we drop this power, then we subtract 1. So that's 7 into x cubed plus 2. We subtract 1, 7 minus 1, which is 6. Then this part now is the first derivative of the f of x that we are given, which is x cubed plus 2. What is the first derivative of this function? So we are going to drop the exponent, subtract 1, 3x, we subtract 1, that's 3x squared. It's a constant, it gives us a 0. So you're going to have 3x squared in this case. So be very careful in your simplification. So we can multiply 7 times 3, which is 21, x squared into x to the exponent of 3 plus 2 to the exponent of 6. So this is your final answer, which is the derivative of the whole part that you're given. So it can be any algebraic expression, any trig function. So even fractions can be converted to this derivative. Why? Let's say we are given, in this case, y, which is equivalent to 1 over 1 minus 4x to the exponent of 3, like this. I'm not worried about the format that I'm given. If I understand this derivative to say, we are going to have the first derivative of f of x multiplied. If I understand this concept, I'm not even worried about the format of what I'm having inside. So, okay, so the first thing that we are going to do is to have this as as a fraction, I mean, as a term that is being raised to a certain exponent, not 1 over. So from our laws of exponents, we can write this as to the exponent of -3. So meaning we can rewrite this as 1 minus 4x to the exponent of -3. Remember, x to the exponent of minus a is equal to 1 over x to the exponent of a, which means even a function, when it is raised to the exponent of -a, we can write this as 1 over that function to the exponent of a. So that is what we simply have in this case. All right, so here it's a vice versa, from a fraction to the number to a certain power. So that is what we have, number to a certain power, that is a bracket to a certain power. So this is your f of x, which is the function, and this is our power. So we are going to have the derivative of the power, that is the derivative with respect to x, the derivative with respect to the power, which is -3. We drop this power, which is -3. We subtract 1 on this power. So this is going to be -4. So it's 1 minus 4x to the power of -4, or to the exponent of -4. Then we multiply to the first derivative of our f of x. So if our f of x is equivalent to 1 minus 4x, what about the first derivative now of this? That is f prime x. 1 is a constant, so we are going to obtain a 0. The derivative of minus 4x, which is -4. So this is our f prime x. So we're going to multiply to -4 in this case. So it's now a matter of simplification, but everything is actually in order here. So you can combine by multiplying the terms outside of the brackets. The -3, the -4 is going to give us +12 into 1 minus 4x to the exponent of -4. Remember, I was saying here, if a function is being raised to a certain negative exponent, we can write this as 1 over that function to the exponent of a positive a. So meaning we can rewrite our final answer as the derivative of y with respect to x is going to be 12 is going to multiply our answer, so it's 12 over. This part is the one that is raised to a certain negative x, which is -4. So it's raised to the exponent of -4. So it is going to be 1 over f of x to the exponent of n. That is 1 minus 4x to the exponent of a positive power now, which is 4, not n. Here we are given 4. So it is going to be a +4. So that is what you're going to have on your final answer on this derivative. So as you can see, questions can be easier like this. It's just a matter of trying to simplify properly whatever that you're given. Sometimes they might even give us questions or expressions under the square root, just like this question. Let's say we are given that y is equivalent to the square root of 2 plus 3x. How are we going to differentiate this? Remember, the square root from our laws of exponents is same as to the exponent of a half. So this is 2 plus 3x to the exponent of a half. So we have the power, the function of x. So using the same concept, we are going to determine the derivative of y with respect to x. Drop the power, then subtract 1. That's 1 over 2 into 2 plus 3x to the exponent of, if we subtract 1 in this case, this is half minus 1, which is, so that's a -half in this case. So this is a -half. So from the derivative that we are having, we can simplify further because this whole part is raised to a negative exponent or a negative power. So to remove the negative, that is going to be 1 over the bracket that you're given. So that means that y dx is going to be a half times, this is going to give us 1 over 2 plus 3x. So this is going to be 2 plus 3x, everything to the exponent of a positive. Now, to remove the negative, that is the introduction of 1 over the inverse of. So the inverse we have removed, but this is going to be a positive at the end. So it's going to give us a positive half. So as you can see, this part we can just multiply, direct the numerator to the numerator, 1 times 1, which is a 1 over 2 times this part raised to the exponent of a half. But we know that to the power of a half, just like what we had before, it was a square root. Then we raised it to the power of a half. So this time it's a reverse. From to the power of a half, we know that it represents the square root of. So this is going to remain as the square root of 2 plus 3x like this. So this is how you can present your final derivative. So in this case, we had the derivative of the power. Okay, sorry, I was actually affected by the network. So this, I forgot to put the first derivative in this case of x, which is 3. So this is going to give us 3. So we multiply also by 3. We also multiply here by what? By 3 again. Let's correct this part. So if we multiply by 3, this means this answer is going to give us a 3 at the end. So here we are going to have a 3. So let's correct this part. So we are going to have it as 3 over 2 square root of 2 plus 3x. Okay, so these are typical questions that you can be given. So like I was saying, depending with the question that you are given, you can perform any calculation. So now we're focusing on algebraic expressions. So that's why my questions were based on algebraic expressions. So we shall have the same consideration even with the trig functions. So we just wait for that one as we are revising other classes that we have done for now. But we shall have that platform. But for now, that's it, guys, from Mason African Motives. Till we meet again.